Hey, welcome back to another video. I've been skirting an issue for a long time. I've been skirting this issue of putting together slope and intercept since, man, like, I don't know how many videos ago, but for a while. We've been doing this thing with, hey, these lines, they cross the y-axis, yay, and they go up or they go down by this rate that compares how much you go up to how much you go to the right. It's called the slope, and we've been going round and round and round about it. We did a formula for slope. We know how to find the slope between any two points. Last video, what we did is I gave you a point and I gave you the slope, and I said you can graph with it. It's pretty easy even. You just have to know the point, plot it, and then go up if it's positive, down if it's negative, always to the right to find the next point. Use those 2 points, graph the line. That was basically the last video. And then I left you with one concept. The concept was, what if I don't give you a solid point, I give you a y-intercept? That is a point. It just has an x-coordinate of 0 every single time. That actually makes it even easier. So what this lesson does, what this video does, is that runs with it. It says, well wait a second. If you can find the slope and you can find the y-intercept from the function, from the formula, from the equation line, then can't you graph it pretty easy without having to plot points? So we're going to explore that in this video. I'm going to show you how to find the slope and the y-intercept, not just any random point, the y-intercept, where we cross the y-axis every single time in what we call a linear equation. So we're going to talk about this thing called slope-intercept form of a line. There's some key points to it. I'm going to go through it. I'm going to introduce it very briefly because I've done the introduction throughout the last several videos. But let's check this out. Let's suppose that we have y equals 2x plus 1. Now, we could plot this with points. We could plug in 0 and get 1. We could plug in 1 and get 3. Hopefully you can do that with me. 2 times 1 is 2, plus 1 is 3. We always plug in our x numbers for x's. We get out y values. Input for the x, output for the y. You plug in 2, you get 5. And that gives us 3 points. Do we need 3? No, but because I'm trying to introduce this again, because I'm trying to explore this a little bit, I'm using 3 because I want you to see what goes on here. 0, 1, what's that called? What's that called when we have a point on the y-axis? It's a point of our graph on the y-axis. That's called it's your y-intercept right there. If I go 1, 3, and 2, 5, of course it makes my line. The key isn't just to make your line anymore. I don't ever want you graphing lines with plotting points ever again. We've learned way better techniques. We've learned the intercept method. That was really cool where we covered it up. Do you remember that? We covered up stuff. It was like 5 seconds. We were done graphing. That's awesome. Not everything works for cover-up method though, so we need a new method. I'm going to show you why everything doesn't work for cover-up method in just probably a couple more videos. But if we graph that line through those 3 points, sure, we get the line we want. But plotting in value, plugging in numbers is man, it's prone to errors. We make a lot of mistakes on it, especially when we have negative numbers and fractions. Can we get the same thing quicker? Here's what I've been trying to get you to see for the past several videos. These numbers here relate to how your graph looks. Now, there's the biggest thing I can tell you. Don't miss this. I'm begging you, don't miss this. In order for any of this stuff to work, in order for slope-intercept to actually work, you have to have this equation solved for y. If it's not solved for y, this stuff doesn't work at all. So slope-intercept form, you have to have it solved for y. So you make sure, if you're trying to find slope, if you're, whatever you're doing says, hey, find the slope, you got to solve this problem for y. So you've got to take some time, make sure that we have y equals. All of these on the board are set up perfectly. That's exactly what we want. Next few videos, I'm going to show you how to set it up perfectly. But right now, this is what we're looking for. Y equals, y equals, y equals, y equals, y equals. All of the time, y equals. That is how the slope-intercept form works. It does not work any other way. It's the only thing that we can do to find the slope and the y-intercept in the equation of the line itself. We have to have it solved for y. I hope I made myself explicitly clear on that. So if you have it solved for y, it's awesome. Because check this out. That 1, when you plugged in 0, everything disappeared except that 1. When you plug in 0, you necessitate that you're going to be on the y-axis. That's awesome. If you plug in 0 here, your y value is 1. Plug in 0 here, your y value is 1. Your y-intercept is 1. You plugged in 0 for the x. It said you're on the y-axis and you got out a 1. That constant, that number, will always tell you the y-coordinate of your y-intercept. 100% every time. So you could literally look at this equation and say, hey, I'm solved for y. Now, why is that important? If I'm not solved for y, if I have other crap over here, if I plug in 0, y might be added or subtracted or multiplied. It wouldn't equal 1. So I need this to be y itself. That way, when I plug in 0 for x, the only thing I have left is y equals a number. That's why you have to have this solved for y. So just by looking at the constant, I can find the y-coordinate of my y-intercept. Guaranteed it's 0, 1. Those are the same ones, just like we thought. Now the slope. The slope is what tells your x how to behave. It says I'm going to plug a number in and I'm going to multiply you by something. That multiplication, that's the rate at which we climb and go over. That's the slope. If you have it solved for y, it's always the number right in front of your x. Look at the number in front of x. It's 2 over 1. That's crazy. Remember that we can change any whole number into a fraction just by putting it over 1, and that's exactly what this tells you to do. From point to point to point, we go positive. Why are we doing positive? Slope is up when it's positive. Up 2, positive 2, to the right 1 over 1. Up 2 over 1. Does that work every time? Because that would be awesome if it worked every time. The answer is yeah. If you had that solved for y, every single linear equation, every single function, every single equation that makes a line, equation of two variables that makes a line, can be written as that form. Y equals mx plus b. Every single one of them. If you have an equation that the graph of that is going to be a line, you can write it as y equals mx plus b. Is it always the best choice? No. I've shown you intercept method. It is wonderful. But if you're ever asked for the slope, listen carefully here. I just told you another method works great. But if you're asked for slope, that's the only way to find it. This is the only formula that lets you graph easily and has the slope explicitly written. So that means it's pretty important. It's important for you to be able to solve for y because we oftentimes have to deal with the slope, like a lot. So y equals mx plus b, that's what this form is. Notice where we got these numbers from. The m, oh my gosh, m means slope, that's awesome. The m is the number in front of the x. Please make a mental note. M does not include the x. So when I'm talking about any equation can be written for a line, can be written as mx plus b, the number in front of the x, the coefficient of x, represents your slope. That's it. It's the relationship that tells you, you plug in a number for x, it's telling you how far up to go. That's the multiplying factor, how far up or how far down if it's negative. And B, get this right, a lot of people just have this misconception that B is a number that goes on a line. It is and it isn't. In order to plot points, you actually have to have points. So I'm going to say this very specifically, and I know that a lot of teachers, they don't, and they just go, oh yeah, just plot 4. Well, that gets confusing for a lot of students. If you're just going to plot 4, or plot 1, or plot -2, well, where do you put that? Yes, it's on the y-axis, but that means that it has a point. It's 0, something. I want you to understand that B is the y-coordinate of your y-intercept. So what I'm going to have you do, I'm going to have you write out the B, sure. Y-coordinate of the y-intercept. But I've seen too many students lose their way on this. You're like, oh, I forgot what that means. So after you write down the B, like B equals 1 in this case, I want you to go a step further and give me the point. Give me the point as Well, how did you even get in the first place? The only reason that this represents the y-coordinate of the y-intercept is because when you plug in 0 here, you get y equals that number. Check that out. Follow the logic here. If I plug in 0 for x, this whole thing's gone. If I plug in 0 for x, I'm on the y-axis. I have to be. Every single point that has x as 0 is on the y-axis. So if I plug in this, x equals 0, I'm on the y-axis. It gives me the y-coordinate of that on the y-axis point, the y-intercept. So if I plug in 0 for x, I'm getting the y-coordinate of the y-intercept. I want you to write this out as that, as 0 comma b. Give yourself a point. And you know why I'm doing this? If you watched the last video, that's exactly how we graph lines. It's so cool. It said, oh, hey, if I give you y-intercept, we have a point. How many points do you really need to graph a line? Well, 2. I give you 1 with the y-intercept, and you find the next one with your slope. That's it. So y-intercept gives you a point, 0b, 0 comma the y-coordinate of the y-intercept. That's it. And then your slope is how you find the next point. Very cool stuff. Today, for the rest of our video here, all I want to do is identify that these are in slope-intercept form, identify what the slope is, identify what the y-intercept is. That's it. In the next few videos, we're going to start graphing with them. So that's kind of cool. It'll be very quick. You're going to like it because it takes at most like 5 seconds to graph a line. It's awesome. So let's look at them. Are these in the right format for slope-intercept? Slope-intercept does one thing. It says solve for y, put the other side in order, where you have x's first and constants second. X's first, constant second. X's first, constant second. Oh crap, there's no x's. That's okay. Constant is up there. X is first, there's no constant. That's okay. X is first, constant second. X is first, no constant. That's fine, as long as they're solve for y on one side equal to x is first with a constant second. That is slope-intercept. We're going to go through, I'm going to do about the first 2 of them with you. I want you to do this one on your own. I'll pause for a second. Then we'll talk about some weird ones so they get a little funky. So the first thing I want you to do is make sure they're in order, make sure that you have solve for y, and then we're going to literally write out for now what the m is, what our slope is, and then what our y-intercept is. So the first thing, your slope, if you have this in slope-intercept form, your slope is always the number associated with your x. It's the exact same thing that we've done here, but I want to show you how much faster it is without plotting points. So we go, okay, there's my x. It's the number right in front of it. Positive, you take it positive. If there's a negative, you take it negative. But my slope is 2. Write it as a fraction. 2 over 1. What's that tell you? Should that line be climbing or falling? Should be climbing. How much do I go up? I go up 2. How much do I go to the right? Always to the right. I go up 2 over 1. Exactly what this says. Do you need points to do that? No. You just need the slope and a starting point. Your b, well, your b is 1. Your b says, what's your constant? If I plug in 0, y would equal 1. Your constant is 1, positive 1. If it had been minus, you'd have negative 1. We have 1. Now, I want to go further, though. I know that that's the y-coordinate of the y-intercept, but I want to make sure that I have a point. I don't want to get lost on where the 1 is. This is part of the point 0, 1. That's exactly what this says. Can you see, like, going forward, if you knew this, that'd be pretty easy to graph. Just like the last video, you go, well, hey, that's a 1, I'm going to have 0, 1. Put a point. That's a 2, I'm going to have 2 over 1, up 2 over 1. You just graphed a line in like 5 seconds. That's cool. Let's do the next one. So, first thing I'm looking for, I'm trying to model my thinking for you. I got y equals, that's great. I've got stuff in order, x is then constant. The first thing I do is I find my slope. The letter we use to represent that is m. I'm going to look right in front of the x. I don't include the x, I look right in front of it. I say, oh, hey, it's negative 1/2. You're also noticing that if I have a negative in front, I'm automatically putting it with the rise, putting it with the numerator. And then I'm stopping for just a second and I'm thinking about how this line should look. So if I'm going to graph this line, I'm trying to get you for the next video, okay? Trying to get you to kind of think about this. But I'm going to graph this line. My rise is negative. I would drop down 1, numerator's 1, negative 1, and then I go to the right 2 spots. So I'd be going down and over, down and over, down and over. My line should be falling. Down 1, over to the right 2. The next piece I'd be looking at would be my b. My b is 1. I'm going to go a little further. I'm going to understand that if my b is 1, that b would be from plugging in x equals 0. My y would equal 1. If I plug in x equals 0, I'm on the y-axis. Y is 1. That's my y-intercept there. So this is giving me my y-coordinate of my y-intercept, which has to have an x value of 0. Plug in 0, you get 1. That tells you your y-intercept. Same y-intercept as before. That's kind of interesting. But the line's going to look different. So here we'd have a 0, 1. Try to kind of put yourself through graphing this. You'd have 0, 1. You go just up 1. And then from there you go down 1 over 2. And you'd make your line. Cool. Without having to plot points. If you haven't, I'm going to give you a moment to do that. Do at least the slope. So find at least the slope of that. And then what I want you to do is, if you can, find out what your b is. Remember that with your b, you're going to take the sign that goes in front of it, just like slope. Terms are always associated with the sign in front of them. So think about that. Your m. So that's in order. I love it. Solve for y looks really good. I get x has been constant. That looks great. I know that my slope doesn't involve the x. It's just the number in front. It's the fraction in front. Goes with the sign though. So that's negative 3 over 8. Negative 3/8 or negative 3 over 8. Next thing I do, I look past the x. That's why these have to be in order. So you're geared in onto what to look for. If I plug in 0 for x, notice how I don't cover up that negative 2. Oh, don't do that. I cover up this. Y would be negative 2 if I plug in 0. The b is negative 2. The constant there, it goes with the sign. So we're thinking, I know it says minus 2, but we say minus, we kind of think negative. That term is negative 2. Now, what is that? If you plug in x for 0, that's the only freaking way that you got the negative 2. If you plug in x as 0, it gave you negative 2 for the y. That's literally why we get the y-intercept out of that. Yeah, we make it pretty easy. We just go negative 2. But you're plugging in 0 to get that. That's why it creates a point, 0, negative 2. Now, go through the process of trying to graph it. Could you graph it? Could you start with the point at 0, negative 2? It's your y-intercept. From that point, could you go, where would you go? Would you go up or down? That's your slope telling you. Go down 3, and then go to the right, always to the right, always run to the right. 8 spots. Graph your line, it should be decreasing. That's what we're going to be doing in the next few videos. Now for some weird ones. What in the world? Where's your x's? Well, I don't have one. Is it of this form? Yes. Yes, it is. In fact, this is going to be weird and blow your mind here. But how many x's do you have? Like how many are there? 0. Wait, 0 x's? Yeah, exactly. There's 0. Whoa, this is going to be free. 0 x's. I'm not saying ox, okay? Y equals ox plus 4. No, I'm not doing that. But there are 0 x's. That doesn't make any sense. Think about this. If I were to have you graph y equals 4, man, this is cool. What variable doesn't it have? X's. That means that I can't touch the x-axis. True. Show me a line that doesn't touch the x-axis, and I'll show you a horizontal line. So this says you have y equals 4. Do you remember horizontal and vertical lines? That's kind of cool. That's a horizontal line. Wait a minute. What slope does horizontal lines have? Do horizontal lines have? 0. What? It's the same thing. So y equals 0x plus 4 says you have a slope of 0. That's true. Horizontal lines do have a slope of 0. That's crazy. It still works. Your m, there are no x's. The way we say no x's in math is with a 0. No matter what x is, you'd multiply it by 0. That's 0. Plus 4. Oh, it's going to be 4 every single time. Y equals 4. Your b, well, cover up the x. Plug in 0 for x. It's doing that automatically. It's your constant. Your b is your constant. Now, does that make sense to you? Man, I'm really hoping that it does. That if you have a horizontal line at y equals 4, it's going to have a y-intercept at 0, 4. It's going to touch the y-axis at 4. It can't do otherwise. It's not even moving up or down. It's only going horizontally. So your b, unsurprisingly, is 4. And you have a y-intercept of 0, 4. Go through that one again. That's weird for a lot of people. If you're like, what just happened? You're not alone, okay? That's a horizontal line. We've studied them before. Horizontal lines do have a slope of 0. I'm just trying to get you to see that it still fits that formula. It still fits a slope-intercept. So if you don't have any x's, you can always put in 0 times x to represent that. You don't have any. 0 times x would still maintain that. I don't have any x's. How many? 0 of them. But it fits our formula. And it fits this and says, hey, what's the number right in front of x? 0. That's my slope. Makes sense. Horizontal lines do have a slope of 0. It says no matter what you plug in for x, I'd be multiplying it by 0. Your x does not allow you to change. That's what that's saying. It says there's 0 change allowed. You don't go up, you don't go down, you're not changing. That's what gives you horizontal, folks. That's it. And then you add 4 to it. That plus 4 gives you back the 4 every single time, which is why you maintain that level of 4. So slope of 0, cool. Y-intercept of 4, plug in 0 for x, doesn't even matter, you're still going to get 4. That's your b. So you touch your y-axis at 4, give yourself a point 0, 4. That's the idea, kind of funky. Now, what are the rest of them? What about that one? Is it of the right form? Well, looks like it, y equals, but I have an x, I like that, but what's back here? You know what? Very similar to this idea. I didn't have any x's, I put 0. If I don't have any constants, what's the way you say you don't have anything in math? How many constants do you have? I don't. Put plus 0. That's totally fine. That's now the form. So this is y on one side. This is in order. I got x's and then I got constants. I don't have any, but I can put plus 0. Now we start looking for our slope. And I'm guessing at this point you can probably do it. Well, our slope, our m, is positive 5/3. What's that mean to you? Is this line going to climb? Is it going to fall? How much is it going to climb? What's your rise here? This should be going from point to point to point, up 5, right 3, up 5, right 3, forever. Now, in order to start somewhere, you've got to give yourself a starting spot. That's your y-intercept. So your y-intercept is the same thing we'd always do. And you need the 0, really. If you plug in 0 here, you would get 0. Plug in 0 for x, you're going to get 0. Your b is 0. Remember what you're doing. You're plugging in 0 for x. That's always in the y-axis. That's also going to give you a x coordinate of 0 every single time. So you're always going to get 0 comma something for your y-intercept. In this case, we plugged in 0, we got out 0. We plugged in 0 here. You need that. You got out 0. Your y-intercept is 0, 0. You're going through the origin. Think about how you would graph this particular one. You'd start at the origin, and then you'd go up 5 over 3 for your next point. That's interesting. This is the only time that your slope ever starts from the origin, is if your y-intercept is at 0, 0. That's kind of cool. Okay, with that in mind, we got 2 more. They're not super hard ones, but I just want to make sure that you all understand what's in front of your x here. That's what I need you to understand. This is obviously in order. You have y equals, you have your x's first, then you have your constant last. The first thing we do is we start with our slope. We write that down. So we're looking at the number in front of x. It's not 0. That's another common misconception. Students go, wow, well there's nothing in front of your x, so it must be 0. No, we had to literally put 0 when we wanted 0. So if I don't literally put 0, I have a number there. And the number up there is this implied 1. The reason why we don't write the 1, why you'll never ever see this, why don't we write that? Well, the number next to a variable implies multiplication. Well, we also know that that's the multiplicative identity. That's a really fancy way to say if you multiply a number times 1, it's going to give you back the number. So this is saying, hey, multiply 1 times x. And you go, 1 times anything is anything. So 1 times x gives you x. You go, yeah, you're right. Let's put the 1. Now you're saying 1 times x. Oh, that's x. I gotta do it. Now you're saying 1 times, And you just keep on going. It's a redundancy. It creates this redundant, repetitive loop that we can't get out of. That's why we don't write the 1, because the 1 is saying you're doing 1 times something. 1 times something always gives you the something. So we don't write it, but what that means for us is that there is a 1 up here, right there. So our slope is the number in front of x. We write it as a fraction, 1 over 1. How does that look to you? Is that line going to climb or fall? Well, it's positive. It's got to, from point to point, go up 1, right 1, up 1, right 1, up 1, right 1, all the time. The constant, we've kind of made it through here. The constant, if you plugged in 0 for x, you'd get 1 for y. That means your b is 1. That translates to a y-intercept of 0, 1. Are you starting to get the picture that your x value, your x coordinate, is always 0, and it's going to be associated with your b? That creates a y-intercept for you. Last one, it's the most basic. It's one of our basic graph shapes that we get to transform and translate when you get to about college algebra or pre-calculus. But it's really weird because there's not a lot going on. I mean, what's going on? It's the most basic line that we really have besides a horizontal. It does have a number in front of it. We just talked about it. It does have a 1. It is solved for y. Y equals x's come first. Constants come second, but there aren't any. That's what that line does for you. This has a slope of 1. So we write that as 1 over 1. This has a y-intercept. Plug in 0 for x, you get 0 for y. This has a y-intercept of 0, 0. Your b is 0. Gives you a y-intercept of 0, 0. You could graph that one as well. We'd start here at the origin. We'd go up 1 over 1. We'd start here at 0, 1. On the y-axis. From that point, you go up 1 over 1. Are you getting that you don't always start from the origin? There's only one case where you'd start from the origin. It's when you have a y-intercept of 0, 0. That's the basic idea. Now, the last thing for this day, before we go any further, walk yourself through these examples again. Get quick with them. Make sure you understand the basics. I have it solved for y. I have my x's first, my constants second. If I don't have x's, I can put 0x. If I don't have constants, I can put plus 0. Find your slope first as a fraction. Find your b second and make a point out of it, 0, comma b. If you can do that, then the next video we take point, plot it, take slope, find next point, graph line. That's pretty cool. All right, so the last thing. I want to see if we can take a couple lines that are given to you, if you can find slope, y-intercept from them, make equations. That's really useful because if we can take a line and make an equation from that line, we can do math with that equation. That's neat. So let's see if we can do this. Oh, yeah. They're the same. So suppose you're given a line and asked to write the equation of that line. Could you find these two things? Because if you can find the slope and if you can find the b, then we can go right back to the equation of that line. Let's write out right now on your own, write out what the y-intercept is. Write it down. Crosses the y-axis, got a point, find the point. We're going literally backwards, like for real backwards. If this crosses the y-axis at 0, -2, then immediately, just like it, and this is why I had to practice, guys, Just like we went from B to the actual point of the y-intercept, we can go from the point of the y-intercept back to our B. Your B has to be -2. Now your slope, we're so good at slope. You guys have learned a lot. If you've made it this far in the videos, you've heard a lot about lines and slopes. Slope is how we get from point to point to point. So as we're going from left to right, do we climb or do we fall? How much do we have to climb? Remember, this is rectangular coordinate system, so it's an up and it's an over. We'd have to climb up 2 and right 1 to make this go from point to point to point. Up 2, your rise is positive. Put 2 on the numerator. Right 1, your run is always positive. It's always going to the right. Right 1 on the denominator. From there, man, we're actually good to go. If you take these two numbers, m equals 2 and b equals -2, you can write your equation. Come on, if I wrote it correctly. You can write your equation as mx. Yeah, I know I'm not writing as a fraction. We're going backwards. So we're taking fractions and simplifying them if we can. mx plus b, or minus b if you have a negative. That's the same exact graph. Check it out. Can you go backwards? Could you look at it? It's kind of neat. This is your y-intercept. This is your b, your y-coordinate y-intercept. -2 says you get 0, -2. You're there. This says you go up 2 over 1. Remember the fraction. Up 2 over 1, up 2 over 1, same line. That equation describes that line. That's how we go from a line to an equation. Last one I'm going to give you. Maybe you could try it. See if you can do that one. See if you can find B. See if you can find the y-intercept right as a point, then translate that as B. After that, find your slope. Do you got to go up or down as you're moving from left to right? Write down your slope as a fraction, translate that into equation. I'm going to get going on it right now. So I know that the first thing I look for is my B, where across the y-axis is at 0, 0. That's the point. Since B is the y-coordinate of that point, I know B is 0. Next thing I look for is my slope. I start from the point on the left of them given that I found, usually it's just my y-intercept. I look whether I'm going up or down. I'm clearly dropping as I'm going this way. Down 1 over 1, 2, 3. Down 1, your rise has to be your vertical motion. So down 1 means -1. To the right 3 means my run is 3. I'm almost done. All I have to do is translate this back into my slope-intercept form. Y always equals slope first, then variable, and then plus or minus your constant. Here, we could put +0. But at the very end, you're going to want to go, well, that +0 doesn't do anything. If you add 0 to anything, that's the additive identity. It doesn't change the value. I don't need the 0. In fact, we put the 0 in previous examples just so we could say that B was 0. That means that if B is 0, we really don't need that. That's the equation at line. And really, you can see it. There's no constant. That's a 0 constant. That's a 0 y-coordinate. That's a y-intercept is 0, 0. We go down, our numerator is -1. To the right 3, we graph a line. It's representing the same line. That's the idea. I hope this made sense to you. I hope that at this point you're feeling very comfortable with finding slope and the y-intercept from these equations. Because in the next video, we're going to do the same thing, and then we're just going to graph them. It's going to go very quickly now that I've had you master this stuff. You should be feeling pretty confident about it. You guys can do this. It's going to be awesome. And by the end of these videos, you're going to be able to graph lines like it's no one's business. I'll see you for the next one on how to actually graph with slope-intercept.